All right, in this video, we are moving on into section 3, solving trig equations. Up until now, we've been using the identities, and we've had expression equal to an expression. Here, we are going to actually solve trig equations, and to do that, we're going to need to be reminded of some of the things we've already learned about sine and cosine and tangent functions. In fact, all trig functions and what they look like as a graph and also as they look on a unit circle. This, as you can see in front, is a graph of, or partial graph of sine theta. Y equals sine theta is the equation. There's an equal sign in it. Now, one thing I want you to remember, many things I want you to remember, is that these graphs go on in the positive infinity direction forever and in the negative infinity direction. And then they bounce up and down on its range. And if it's just y equals sine theta, this is -1 and 1. And so remember that the amplitude says it goes up, and then it goes back down, and then it goes up, and then it goes back down. And so this continues on forever in both directions. When we talked about a period of sine is just one of the patterns that gets repeated over and over and over again. The one period is not the only part of the graph. It goes on in both directions. So, for instance, what would be the domain of the graph of sine? Well, the domain is going to go from negative infinity to positive infinity. It goes on forever in both directions. The range, however, bounces from -1 to 1, and I'm writing that in interval notation, which means that the brackets here mean that it includes -1 and 1 in the domain and the range. Okay, so for instance, if this is y equals sine x, I know that this on the x-axis is 2 pi, and here is pi, and once again is pi over 2. All these angles are going to be in radians, okay? And then over here we have negative pi over 2, hard to write. Here we have negative pi, negative 3 pi over 2, and negative 2 pi. Okay, so you can see here that the quadrants, you can also see quadrants here. So for instance, from 0 to pi, right, that is not one quadrant. 0 to pi over 2 is quadrant 1. Pi over 2 to pi is quadrant 2. Pi to 3 pi over 2 is quadrant 3. And 3 pi over 2 to 2 pi is quadrant 4. And if you think about sine, on the unit circle, and on sine is positive in the first quadrant, it's positive in the second quadrant. You can see that sine is above the x-axis. It is negative and negative in the third and fourth quadrant, right, because it's below the x-axis. You can see it here. So what you can see is that even over here at negative pi over 2, is going to be negative. Sine is going to be negative. Well, where is negative pi over 2? Well, it's down here on the unit circle. And at negative pi, it's still going to be negative all through here and then back this way positive. So this way, you can see, corresponds to this negative along here. And then back this way corresponds to the positive leaning here. So you can see that the unit circle and the graph of sine theta is going to be related, and the domain and the values. So for instance, if I want to know what the sine of pi over 2 is, the sine of pi over 2, then I come here to pi over 2 and I look on the graph, and the graph is at 1. So the sine of pi over 2 is 1. Well, what's the sine of 0? Well, I go to my graph, and I see that where x is 0, sine is also 0. And the sine of theta, here's a different way to say it, the sine of theta equals 1. It says, so for what angle theta is sine equal to 1? So I come up here and I look right here. Here is 1. Okay, and if I draw that in, you can see that I'm going to have multiple answers, right? It's going to be here, it's going to be here, and eventually it's going to be over here, and eventually it'll be that again. So there's going to be more than one answer for this, more than one answer. So here's my question. If there's more than one answer, how many answers are there from 0 to 2 pi? Well, there's just one answer from 0 to 2 pi. So if I say, if I just want my answer to be from 0 to 2 pi, the answer would be theta would be at pi over 2. One answer. But if it's not, then it would have to be pi over 2, and then again pi over 2. So it would be every 2 pi, every iteration of 2 pi, positive and negative. Same deal for cosine x. You can see this is a cosine graph. This is still, these are still angles and radians, right? You can see that it's at 3.14, so pi is about here. 6.28, right, is about here. And so you can still see that, that this is still still in radians. So the domain is still from negative infinity to infinity. It goes on forever. These are parentheses, not brackets. And the range is still, these are brackets, -1 to 1, because it still oscillates up and down between -1 and 1. So for instance, what if I want to know for what angle is the cosine equal to -1, right? So here's the cosine. This would be the y value, right? And you can see here that that over the entire domain, it's going to be more than 1. Now, if I just want to know what the answer is from the domain of 0 to 2 pi, right? Notice it contains 0 but not 2 pi. Then that's just one value, and that would be at pi. But if I wanted to do the whole domain, which is from negative infinity to infinity, then I would have to add all those iterations, and they would all be 2 pi apart. Now, here's another way to think of this. On a unit circle, this is pi, right? So this is where the cosine is equal to -1. Well, it's this one, and then remember the coterminal would be this plus 2 pi. So it'd be 2 pi and 2 pi and 2 pi. So because it would happen or occur every 2 pi in. So this is the answer if I just want the answer between, this is the answer if I just want the answer between 0 and 2 pi. This is the answer if I want every single angle that could possibly be for cosine theta equal to -1. Now, another way to think of this would be like, say, for instance, I wanted to do the cosine of 1/2. This is 1/2. So what angles is the cosine of theta equal to 1/2? Well, it occurs here, and here, and here, and here, and here, and here. It's going to be in 2 quadrants. Do you see? So this one is going to be, this one is where the cosine is positive 1/2, which will be in what 2 quadrants? Cosine is positive in the first and the, that's not right, first and fourth quadrant. First and fourth quadrant. All right, so what is the angle in the first quadrant? Well, the cosine of pi over 3 is in the first quadrant, pi over 3. But in the fourth quadrant, that would be this one, this would be 5 pi over 3. So there would actually be 2 answers. Pi over 3, that's this one right here, and 5 pi over 3, which is this one right here. But you can see that that's only over the domain 0 to 2 pi. If I do them all, then I would have to write them as I did down here with the pi plus 2 pi in. And further, I would have to do that for both of them, because if I do this one, this is pi over 3, this is pi over 3 plus 2 pi, plus 2 pi, and it never ends up here. So this is 5 pi over 3 plus 2 pi plus 2 pi. Just a quick reminder of the unit circle. You know, we talked about this being 0 and pi over 2 and pi and 3 pi over 2 and then 2 pi. And you know 0 and 2 pi are the same angle. That's why many of the domains are from 0 to 2 pi, but it doesn't include 2 pi because they're the same angle. In the first quadrant, remember that everything's positive. So sine is positive, cosine's positive, and then tangent's positive. In the third quadrant, sine's negative, cosine's negative, but tangent's positive. In the second, so that's third quadrant. In the second quadrant, do you remember the all students take calculus? So here, everything is positive. All things are positive. In the second quadrant, the only thing that's positive is sine, students. Cosine and tangent are both negative. And then take, tangent's the only thing positive in the third quadrant. And then calculus, then the only thing is positive in the fourth quadrant would be cosine. So sine is negative and tangent's negative. Okay, so one more time, whenever you write pi over 6 plus 2 pi n, what this means is that the original angle, pi over 6, which is in the first quadrant, this is pi over 6, is an angle. It means that if I have pi over 6 plus 2 pi n, then I would have pi over 6, and then I would have pi over 6 plus 2 pi, 2 pi, 2 pi, where I can go backwards. I can do this one minus 2 pi, minus 2 pi. The domain, if I have this part right here, is from negative infinity to infinity. If I just have pi over 6, the domain is going to be, just like I have it written at the bottom, 0 to 2 pi, not including 2 pi. So this means all the coterminal angles to pi over 6. And this one just means just pi over 6. Okay, just a couple of helpful hints here. Whenever you see 1 over the square root of 2, that is the same thing as the square root of 2 over 2. Same for this. If you see square root of 3 over 3, that's the same thing as the 1 over square root of 3. So for instance, whenever you have the tangent of pi over 4, that would be the sine over the cosine of pi over 4, which is 1. The sine of pi over 3 is just going to be the square root of 3, and the tangent of pi over 6 is going to be square root of 3 over 3. And that's going to be equal to 1 over, right, the square root of 3. So these two right here are reciprocals of each other. If the tangent is 1, the cotangent will also be 1. If the cotangent is negative 1, the tangent will also be negative 1 because they are reciprocals of each other. Okay, solving a trigonometric equation means finding all the values of x that make the equation true. The primary goal will be to isolate the trig function to one side of the equal sign. All right, so I have, here is, this is number 7. This is 2 sine x equals 1, and I just want the answers from 0 to 2 pi. All right, so x, remember, is an angle, so I'm looking for the angles that make this true. So the first thing I want to do is I want to divide both sides by 2 so that I just have sine x, a trig value, right, trig function on one side, and a value on the other. So I am looking for all the angles of x where sine of that angle is equal to 1/2. So the first question you ask yourself is, where is sine positive? In what quadrants is sine positive? So I'll put the little quadrants up here. I know that sine is y, so this is x, this is y. They would be positive in the first and second quadrant. So I'm going to have 2 answers from the unit circle, 2 answers for x. All right, so that's my second question. The second question is, for what angles x is sine x equal to 1/2? Well, in the first quadrant, x would be equal to pi over 6. In the second quadrant, the pi over 6 angle is 5 pi over 6. So here's the deal. If I take sine of pi over 6 on my calculator, I should get 1/2. But if I also take the sine of 5 pi over 6, I'm also going to get 1/2. There are two answers to this equation. And this is the procedure. What quadrants and for what angles is sine equal? And you write those out. So that's why it's so important that you know the unit circle. Here's another example. I have the cosine of x is equal to negative 1/2. And I just want the angles between 0 and 2 pi. That's my domain. So the first thing is I ask, what quadrants is cosine negative? And so if I draw this little thing, cosine is negative in the second quadrant, because I'm looking at x, and the third quadrant. Okay? So what I need to find, however, is I need to find where is cosine x equal to 1/2, remembering that this is a quadrant 1 angle. But once I have this angle, I can use the reference angles to find the same angle in the second and the third quadrant. All right? So cosine of pi over 3 is equal to 1/2. Pi over 3 is in the first quadrant. So what I need are the pi over 3 angles in the second quadrant and the third quadrant. Well, the one in the second quadrant is 2 pi over 3, and the one in the third quadrant is 4 pi over 3. So those are my two angles. Both of those angles are between 0 and 2 pi, so I am finished. Okay? This idea of a reference angle, this idea of finding the quadrant is huge. You have to know what this is. That's how you'll find it. So this actually has two answers. Okay, here's the problem that I want you to work for homework. You should have had an example to do on each one of these. So I would like you to have this worked. I want you to go from on the domain of 0 to 2 pi only. Okay, and we'll talk more about how to do that. If you think you've got it, you can do the domain of all reals, or negative infinity to infinity, if you think you've got that. But I'd like for you to try it. I'm going to be checking your notebook to see if you have this. So please don't skip it, and I'll see you in class.